Okay, go look at day 3 of quadratic functions, equations of quadratic functions. So when we're looking at these, first I want to know what attributes can we identify when we just have the equation. So when I have x squared plus 4x minus 4, if I were to put in a 0 for x, well, that x squared term would be gone. That 4x would turn to a 0 as well. And so I just have y equals negative 4. So that means when x is 0, y is 4. And that would be, we know about our coordinates on the graph, that would be our y-intercept. So we could figure out the y-intercept. And we can also figure out the concavity, so whether it's concave up or concave down, based on the sign at the front. So if the x squared is positive, it's going to be concave up. If it's negative, it'll be concave down. So negative would be concave down, positive, concave up. Just as a little reminder for us there. So let's graph these. And to do that, I'm just putting them into the calculator. So I'm using the TI-84 today. I've got my first equation in there. And so when I look at the graph, we've got, I'm just giving you approximate, that's about at negative 2, negative 8. And this won't give you an exact, and we already know the y-intercept is 0, negative 4. So I can use those kind of as my guide and get a little bit of an idea of what that looks like. Okay, so not graphing it exactly. I won't have my points exactly, but this gives us at least a general idea. Then similar thing, I know y-intercept here is going to be a positive 2, and then my vertex ends up being 2, 6. And so we can do kind of the same thing and get a decent idea of my graph here. So y-intercept and the direction that it's opening, we can figure out all from that. We can also, just given the standard formula, we could also figure out the vertex using a basic formula. And so it's a quadratic formula simplified down, but that formula would be x equals negative b over 2a. So we'll get our a, b, and c values, and we won't use the c value, but a for this, remember, is always the number in front of the x squared, so negative 1. B is a positive 4, and c is 15. And so to figure out that axis of symmetry, all I have to do is plug in the a and b values to that formula. So x equals negative 4, because that's a negative b, over 2 times a, which is negative 1. And so those two negatives will end up making it positive. And so it's x equals negative 4 over negative 2. When that divides out, I just get an x equals 2. So my axis of symmetry is x equals 2. And then if I know where that axis of symmetry is, like here for instance, I can use that to find my vertex just by plugging in a 2 for x. So y equals negative 2 squared plus 4 times 2 plus 15. And when you do this, make sure you're only squaring the 2, not the negative. It'll give you a very different answer if you end up squaring the negative as well. So 2 squared would be 4, and so that's a negative 4, plus 4 times 2, which is 8, plus 15. So altogether, it's going to equal 19. Sorry, I ran out of room there. So y is 19, x is 2, so my vertex will be 2, 19. And then we figured out most of our stuff there. The only thing we'd be missing is the roots. And we could use the graph, or we could factor that out to get the roots. You've got a couple of different ways that you could do that. This formula over here actually is a way to get my roots. And so if you have this formula, you could just say the roots would be x equals, or you just say the roots are 1, 0, 5, 0, but that's a lesson for another day. We're going to change that so that we can get the vertex and everything else. So let's multiply this out real quick. Give me 2 times, I'll use my FOIL, my claw. So x squared, and then a negative 5 and a negative 1 gives me negative 6x plus 5. And we'll multiply all that by 2. So I get 2x squared minus 12x plus 10. So and I'm going to come over here. A value is going to be 2, B value negative 12, and C value that we're not really using right now is 10. So we'll plug in this formula once again. X equals a negative B, so change the sign, it's a positive 12. And then over 2 times 2, or over 4. When we calculate that out, x is going to equal 3. And we'll just plug in a 3 for x to get the vertex. So y equals 2 times 3 squared minus 12 times 3 plus 10. So when we finish calculating that out, I've got 18 minus 36 plus 10. So that'd be 20. It's like a 28 and a negative 36, which gives me a negative 8. So my vertex is going to be, x value is 3, y value is going to be negative 8. And once we've got those vertices, then that's going to help me to figure out my minimum and maximum, as well as my domain and range. So if I look, since this is negative, anytime it's negative, I'm going to have a maximum. And that maximum value, remember, is my y value, so 19. So I'm going to have a maximum value of 19. And that's going to tell me my range. So my range would be y. Since it's maximum, y is going to be less than or equal to 19. And then my domain, just as a regular function, will still be all real numbers are from infinity to negative infinity. For this one, it's positive, so that's concave up, which means I have a minimum value of negative 8. And so we're going to go opposite of what's happening here. So my y value is going to be greater than or equal to -8. And again, domain, same thing, all real numbers. Okay, so as you look, we've got a couple of examples down here. This is a form we probably won't talk about that when you get up into Algebra 2. This is actually a vertex form that can tell you the vertex just from what it looks like here. It'd be +1, -3. But for us, we're going to continue working them out into that regular formula. So let's just do the one here that we have. So if I put in a 0 for x, my y-intercept would be 0, 1. And then we'll figure out with our formula the axis of symmetry, x equals -b. So b is a -3, so that means a +3 over 2 times 1. So axis of symmetry is going to be 3 over 2. So you're not always going to get a whole number. You can get a fraction. So x equals 3 over 2. Then to figure out our vertex, we have an x value of 3 over 2. And we're going to plug that in to the equation. And so 3 over 2 squared, which would just be 9 over 4, minus 3 times 3 over 2 plus 1. So 9 over 4 minus 9 over 2 plus 1. So a little bit of work with fractions. I need to double these to get 18 over 4. And so -18 over 4, and then 1 would be 4 over 4. So I've got 9 over 4 minus 18 over 4 plus 4 over 4 gives me +13, -18. And so 5/4. It looks like a -5/4 for my vertex. And then it's positive, so it's concave up, which means it's going to have a minimum value of the y value here, -5 over 4. My domain is still going to be all real numbers. And my range is going to be y is, since I have a minimum, everything's going to be greater than or equal to -5 over 4. Okay, so this is using just that formula. You also have the option of checking yourself by graphing it and doing the same thing. But you can save yourself maybe a little bit of time, but works out easily by just using these formulas to do the same.